Hi, this is Miss Hart. Today we are going to talk about the process of science or methodology. Knowing how science works is much more important than memorizing scientific facts. So let's dive into a strategy that will give us practice in thinking like a scientist and understanding the process. How can you organize the entire process of science? I know, right? Sounds pretty daunting. But if we break it down into its components, it's a lot easier to visualize. So I've developed this graphic organizer called the experiment design diagram. It includes all the different components that we need to understand the scientific process. Perhaps in previous science classes, you've been introduced to something called the scientific method. The scientific method is a great starting point, but rarely does the scientific process follow any prescribed route. In fact, if you think about it, science is continuous. The more we know, the more we can find out. This is why it's important to visualize the process and the components that it contains. Let's try one. This is a hypothetical experiment, and please understand that there has been no background research conducted, nor does Professor Hart study oncology. So we're just using this as an example to figure out the parts of an experiment. Professor Hart suspects that drinking Starbucks coffee can cure cancer and conducts an experiment to prove it. The scientist gets 500 male volunteers with cancerous tumors in their stomach. 250 volunteers drink only water every day, while the other 250 volunteers drink 3 cups of Starbucks coffee each day for 6 months. All participants are x rayed at the beginning and the end of the experiment, and the size of their tumors are measured. The percent and decrease in size of the tumor is calculated for all 500 people. The change in tumor size of the coffee drinkers is compared to the change in tumor size for water only drinkers. So, this is an interesting one. Throughout the history of science, there has been one thing that never changes, regardless of time, and that is humans making observations and then asking questions about what they noticed. Scientific questions are unique in that they are testable and measurable. Scientific questions do not deal with supernatural phenomena, but instead ask questions about what's going on in the natural world. So let's get back to Professor Hart's experiment. As you can see here, the professor suspects Starbucks coffee can cure cancer. So, what could a possible scientific question be? Does drinking Starbucks coffee cure cancer? Is this testable? Yes. Is this measurable? Yes. We're going to be moving on to specific parts of the experiment next. These are 7 parts of a controlled experiment that scientists must account for when they're doing their research. Please note that many more research components exist, but this is a great place for us to start. I strongly encourage you to have these definitions written down in your notes. And another good practice would be to complete a sample experimental design diagram as we go through the lesson. If you think you would like to do that, pause this video and open the link titled Experimental Design Diagram in the Buzz lesson. Our first component of an experiment is what's called the independent variable. The independent variable is manipulated by you, the experimenter, and it's changed on purpose. Another way to think about this variable is that it is the part of the experiment that you want to test. Looking at the hypothetical experiment, we can see that some volunteers will get water and some will get coffee. So what is the independent variable then? Because the researcher is changing the type of drink on purpose, this would be the independent variable. If you are taking notes, make sure you're keeping up with the examples. And if you're completing the design diagram, feel free to mark it up with whatever information you feel is important. Within the independent variable, try to imagine the setup of the experiment in the lab. This is where there are different values that are assigned to the changes you make as the experimenter. These are usually referred to as treatments or levels of the independent variable. In this experiment, there are only 2 levels of the independent variable. What are the levels of treatment in this experiment? The researcher is looking at the difference between coffee and water drinkers. It is important to note that one of the treatments, water, is not necessarily a treatment at all. In fact, it is the absence of any treatment. We will find out later why water must always be a treatment in this experiment. Next up is our dependent variable. I like for students to think of data when they think of dependent variables because this variable is always the one being measured. This variable is responding to the changes that were made, aka the independent variable. And not only do we have to know and identify what we will be measuring, but we also have to have an operational definition of that measurement. These are fancy words to simply say, What are we measuring and how are we measuring it? So, what is the dependent variable in this experiment? The size of the tumor is what the researcher thinks will respond to the coffee treatments. And how is it being measured? The size will be measured using x-rays and compared to the size it was originally by calculating a percent decrease. Another important piece of information that defines scientific research is the constant variables. Sometimes these are referred to as controlled variables. In order to claim that the independent variable is affecting the dependent variable, we must first ensure that all other variables are a limited factor in the experiment. These variables could potentially play a role in the outcome of the experiment, so they need to be identified and held constant. Looking at the example, what are the evident constant variables in this experiment? The constants that are explicitly stated are the gender of the volunteers being male, the type of cancer being stomach cancer, and the duration of the experiment lasting 6 months. It is easy to see how if we did not control these variables, they could have a big impact on the results. When doing scientific research, it is important to consider sample size. The sample in an experiment is the number of repeated trials. The bigger the sample size, the better. Large sample sizes diminish the effect of outliers and will improve the reliability of the results. Please note that it is the number of repeated trials per level, and this number must be feasible and attainable. Looking at the example, what is the sample size of this hypothetical experiment? The researcher has a legitimate sample size of 250 males being treated with each treatment. When we hear the word control, you should think baseline sample, or the standard we will be comparing back to. Remember water being one of the independent variable levels of treatment? The easiest way to determine the baseline is to figure out which level of the independent variable is closest to normal, or the one without the treatment. Look at the example. What will the researcher be comparing the data to in this experiment? By comparing the coffee drinker tumor size decrease to the decrease in tumor size of their water drinker, the data could conclude a relationship between coffee consumption and change in tumor size. The hypothesis is a statement about the possible relationship between variables. This means that the hypothesis must be written to include those variables. The if-then statement that is often taught in science classes will work for this class as well. This statement is the testable explanation that the researcher will support or refute with the results of their experiment. The statement will be supported, meaning the evidence agrees, or refuted, meaning the evidence disagrees, depending on the data collected. What is the hypothesis for this experiment? The relationship that is being tested is if the measured decrease in the size of cancerous tumors in the coffee drinkers compared to the water drinkers is less, then it will mean that coffee can cure cancer. What is great about the process of science is that even when hypotheses are refuted, science knowledge is still increased and new questions can and will be generated. This is where the method comes in, and now you can see we've come full circle. I just want to remind you that every experiment we do will give science more facts. But to truly understand science is to understand the process and the patterns of thinking required to do science. So I'm going to leave you with this. Science is built of facts the way a house is built of bricks, but an accumulation of facts is no more science than a pile of bricks is a house. Thanks.